Hey everyone, welcome to another session of CeerazzleDazzle Physics. In today's session, we're going to be talking about colours. Before we start talking about colours, let's first of all talk about white light. So what exactly is inside white light? We can investigate by passing the light through a prism. So we're going to pass the light through a prism, and here it is. So this is white light, and it's going to be passed through a prism. The prism will split up the light into various different colours. The colours that come out are going to be in the following order: red, then orange, then yellow, then green, blue, indigo, and then last of all, violet. So these are the colours of the spectrum which they have been separated out into. Right, so how can we memorise this? It seems quite difficult, but you can just memorise the following statement. Richard of York gave battle in vain. Wonderful stuff. Right, the whole process in which you separate out white light into the various colours, this whole process is called dispersion. So dispersion is the process in which you separate out white light into the various different colours. Easy stuff. Right, there seems to be, quite a number of colours here, but we can look at them in two groups. The first of all, we're going to call some of them primary colours. This is simply a Venn diagram which you've seen in mathematics. We have the red circle, this one over here, red. Then we have blue, and then we have the green. These are all the primary colours, so let's put them down. Red, blue, and green. These are the primary colours. The secondary colours are formed by two of the primary. So the yellow is formed by, so this one is yellow. We can see it's formed by the red and the green. So yellow is going to be made up of red and the green. So red and green make up the yellow. Next one, if I want to make this one over here, this one is going to be magenta. Magenta, so let's put that down, magenta. Let's put that in brackets. Brackets that so you know it's not there. Magenta is made up of which two primary colours? It's going to be the red and the blue. Yeah, and then last of all we have the cyan. This one is called cyan. And it's going to be the combination of the two primary colours, the green and the blue. Easy stuff, so these are the secondary ones. Right, so obviously if I have those two, but if I have all three of them at the same time, right bang in the middle of my diagram, it will be white. Surely that makes sense, because we just learnt that if I split up white light, I get all the colours. So therefore, if they recombine together, they should give me white light. Make sure you know the difference between the primary colours and the secondary ones. Yeah, before we move on. Okay, now, moving on. Let's go. Objects and colour. So why do objects look different colours under different lights? We're going to investigate now. So over here we have a red object. This one is a red object. If I shine white light into it, first of all, which three primary colours make up white light? It's going to be red, blue and green. So it means red goes in, green goes in, blue goes into my object. Right, because it's a red object, it can only reflect the colour which it's made up of. So the red object can reflect only red light, so red light comes out. That's why the object looks red. What about now if we have a cyan object? So we have cyan object now. White light goes into the object, so we still have red, green, blue going in. 1, 2, 3 going in. Right, which ones are going to come out? Right, so it's cyan, so which two colours make up cyan? Do we remember? Let's go back up. Cyan is made up of green and blue. So what happens is, we have the following two colours come out. The green and blue come out. So I'm going to put G for green and blue come out. Therefore they recombine to make cyan. Yeah, so cyan is observed. Because why? The green and blue recombine to make cyan. Right, another one. If I have blue light, so I'm not shining white light into it, I'm only shining blue light into it. So blue light goes into the red object. First of all, can the red object reflect any blue? No, it can't, because there's no red inside the blue. So no light comes out. So the object appears black. So object will appear black. Crazy, yes? So you're right. Because there's no light going into your eye, the object will appear black. What about now if I have blue light going into a cyan object? Think about it before I do it. So blue light. So blue light goes in. The cyan object can reflect which ones? The green and the blue. So cyan can reflect the green and the blue. So there's no green coming in, but there is a blue, so the blue comes out here. So the object will appear blue. Object appears blue. Yeah, so make sure we understand those points here. A little bit challenging. Once you get your head around it, you'll be fine. But if I have depending upon the light coming in, it will change which color the object looks like. Okay, now moving on. What about filters? So filters are dead easy. The color of the filter simply tells you what they let into it and what they don't. So if I have a red filter, oops, that's not the correct color. Let's go. If I have the red filter over here, and I have a blue filter over here, and I have a cyan filter over here. So red, blue, and cyan. The red filter, if I shine white light into it, so let's shine some white light. Which colors are inside white light? It's R, B, G, because those are the three primary colors. So which ones will it let pass through? It will only be the red light. What about blue? If I shine white light into that, so if I shine the red, the blue and the green into it, it's very easy again. It's a blue filter, it will only let in blue light passes through. The cyan filter now, so if I still shine red, blue and green going into it, the cyan filter, cyan is made up of blue and green, therefore it will allow the blue to pass through and the green to pass through. Now, easy, it seems quite easy, yeah, but what happens if I put two filters, one in front of the other? So let's put some white light into both of them. R, G, B going in. Right. If I put them into so this is a blue filter. This is a magenta filter. Right. These three go into the blue filter. So which ones can the blue filter let through? It only lets the blue through. But then it now meets the magenta filter. Which colors make up magenta? Let's have a scroll. The colors that make up magenta are red and blue. So red and blue make up magenta. So is there any red coming in? No, but there is blue. Therefore, the blue can pass through. Easy stuff. Yeah, nice stuff. Right, now test your understanding. Let's do the following. Let's say, for example, if I have red light going into the green book, what color does it appear? First of all, it's green book. There's no red inside the green. Therefore, nothing comes out. So the object appears a black. Now, what happens if I have, right now, let's go for magenta. Magenta going into the book. So which two colors are magenta? It's red and blue. Red and blue go in. But it's still a green book. Is there any green inside the magenta? No. So it still appears black. Yeah, because there's no green coming in. Right, what about the filters? If I shine white light into the filter, so we've got two filters now. I've got the yellow and I've got the magenta. So white light goes in, R, B, G going into them both. The yellow is made up of red and green, so red and green can pass through. There we go. The red passes through. And also the green passes through. But now it meets the magenta, so this is obviously yellow. Now this one is magenta. Now it meets the magenta, which ones can pass through? Magenta is made up of blue and red. Therefore, only the red can pass through because there's no blue coming in. And that's it. It's quite a lot of words going on here, but don't worry, we'll summarize it for you. Right, summary. Let's go. Dispersion is the process of separating light into the spectrum of colors using a prism. So I had the prism, pass white light into it, I separate them out. Next of all, the colours are red, orange, yellow, green, blue, indigo and violet. The order is going to be Richard of York gave battle in vain. Then, objects which reflect colours will reflect colours which they are only made up of. So for example, a red object will reflect red light. A yellow object will reflect green and red light. Colour filters only allow colours through which are the same colour as the filter. That means a red filter will let red light pass through. A cyan filter will let blue and green light pass through. And that's it for today. It's a long session, but I hope you enjoyed it. See you next time for more GCSE fun physics. Goodbye.